So here's question number 2 from the No Calculator section of the 2017 AP Free Response. When a certain grocery store opens, it has 50 pounds of bananas. So it starts off t = 0 with 50 pounds of bananas on a display table. Customers remove bananas. So this is my remove bananas function. And notice it goes from 0 to 12 hours. When f of t is measured in pounds per hour, and t is the number of hours after the store has opened. After the store has been open for 3 hours, store employees add bananas. So this is add bananas. And this happens after 3 hours until 12 hours after the store has opened. So it's important to label things so they pop out when you need to use this information. So part A says how many pounds of bananas are removed from the display table during the first 2 hours the store is open. It's asking how many, that's a quantity, we know it's an integral, have been removed. So that's my remove function during the first 2 hours. So from 0 to 2, I only want to know what's been removed. So I just need to integrate f of t dt. And so math 9, 0 to 2, plug in this function, and you should get this equals 20.05 pounds are removed. Now it says find f prime of 7, and then using correct units, explain the meaning in the context of the problem. Well, f prime of 7, here is my f function, and we're allowed to use a calculator, so this is math 8. Math 8. Plug this into your calculator, this whole thing at 7. And you should get negative 8.12. So what does it mean? We took the derivative of this rate, derivative of a rate, and this rate is the rate at which bananas were being removed. So this is negative. So that means what's happening to this rate? It's slowing down. So 7 hours after the store is open, the rate at which customers remove bananas is decreasing. So 7 hours after the store has opened, the rate at which customers remove bananas is, I'll finish here, is decreasing at a rate of, it's decreasing at a rate of 8.12 pounds per hour squared. Right? This is a rate. It's already a derivative. We're taking another derivative, so hours get squared. Okay, part C. Is the number of pounds of bananas on the display table increasing or decreasing at time t = 5? Well, in order to answer this question, I need to know what rate are these bananas being removed at t = 5? And what rate are these bananas being added at time t = 5? So all we need to do for part C is find f of 5. F of 5. So I plug into this equation, I plug in 5 for every t. And I get a rate of, once you plug this in, 13.796 pounds per hour. Pounds per hour is being removed. And then G of 5, so plug in 5 for my T's here. And we get 11.532 pounds per hour are being added. Therefore, since f of 5 is greater than g of 5, the number of pounds on the table is decreasing. The number of pounds on the table at t equals 5 is decreasing. Since they're being removed faster than they're being added. So the number of pounds is decreasing. And finally, part D. Sorry, this is sloppy. It's hard to record this and look at this all at the same time. How many pounds of bananas are on the display table at time t equals 8? So now they want to know the total amount of pounds after 8 hours, if the store is open for 8 hours. So in order to figure out how many pounds are there after 8 hours, we need to consider the original amount that was there, minus the amount removed, plus the amount added. That will give me my total amount. So again, we know at t equals 0, there are 50 pounds of bananas. That's my original. Minus the rate at which they're being removed. Well, that's my f of t removed. So from 0 to 8, f of t dt plus the amount being added, but be careful here. They didn't start adding bananas until 3 hours later. So at 0, none were being added, but 3 to 8, they were adding more pounds of bananas. And you plug this all into your calculator, and you should get, and that's why I make sure you practice this, plug it in, make sure you get 28.0495 pounds.